Today we're going to be talking about the BytePipe command line interface. Um, what I have right now is I have a BytePipe and the hardware development kit hooked up, and it's connected to the PC over serial port. And then we have the two transmitters and the two receivers connected to a 6-port power splitter, and a signal generator and spectrum analyzer. This allows me to do loopback without overloading a receiver, and it allows me to measure the transmitted spectrum of either transmitter. So what we have here is we have the command line interface. We have TerraTerm, which will connect to the command line interface over a serial port. The setup is just a simple COM port, baud rate 115.200, 8N1, and the serial port does not connect unless the HDK is powered. Once the HDK is powered, code starts executing right away, and you'll miss commands over the CLI. If you want to see those very first commands, I suggest either holding the reset button while you power, connecting via TerraTerm, and then letting go of the reset button. Or what you can do, like we're doing today, is just reset the device after it's been powered up. So I'm just going to hit the reset button on the BytePipe HDK. You can see the first stage bootloader runs, and then from here down is the CLI. You saw it was calibrating. You saw some RF activity. That was because the ADRV is calibrating. What the CLI application is it's just a very basic, bare bones, almost like bare metal, but it does use FreeRTOS application to configure the ADRV, configure DMAs to get INQ data, and then it allows someone to interface the device over a command line interface. That command line interface is available over a serial port or over Ethernet. It's the same interface, you just either connect to a serial port or you connect to the appropriate IP address and port, which we can discuss in a bit here. But so here, the first stage bootloader ran, the management firmware ran, and then from here, the RF-LAN setup, starting from here down, is all from the application. One thing it does is it does execute scripts from the file system on PowerUp. So in this case, it executed rflan setup.txt, which you can put whatever you want in there. I put in, as an example, setting the IP address, and I turned off lightweight IP just because I don't have a Ethernet port connected to it right now, and I didn't want it to sit there and negotiate. It then initializes all the hardware and the ADRV, and then finally runs the ADRV 9001 setup script, which, as an example, I just set TX2 attenuation. You can change those scripts. You can put any CLI commands in those scripts, and comments. So this script here was 1, 2, 3, 4, 5 lines of comments, or 4 lines of comments, a blank line, and then there was the CLI command that was in there, and then this is the response. So the CLI commands are all accessible through help. You can type in help, enter, and it will give you the CLI commands. There's just a few main CLI commands. That's get and set parameters, and there's 2 sets of parameter bases. There's the RF LAN parameters and the ADRV parameters. So if we say ADRV 9001, and we can actually hit tab, it will complete. And then we'll do list params. I'll hit tab again just to autocomplete, and it will tell me all my ADRV params. If I go back to help, I can see that I can get and set those parameters. So we can do ADRV 9001 get param, and we can do, let's just scroll up and copy TX1 sample rate. And I just double clicked it and then right clicked it to copy. That's just a TerraTerm thing. So once I hit enter, it returns the sample rate. You can do the same with RF LAN parameters. Whoops, list params, and there's not very many there. But so the get and set params are a main feature, and then the stream application is another main feature. The RFLAN stream basically combines control of the ADRV and the DMAs, all into one interface. Now you can control the ADRV 9001 separately, through these commands here, but the stream combines the DMA activity and the ADRV into one API. So let's say I want to start transmitting something. I need to load the stream buffer with some data, and then I need to start the stream. So one thing we can do is we can load the stream buffer right here with IQ data from a file on the device. You can also do a buff put, which will put samples that you generate, either from a file, or if you're using MATLAB, you can just create your own waveform in MATLAB and do buff put. Once you do a buff put or a buff load, then you can do a stream start. So I'm going to do list files just to see what's on my file system. And then I can do RFLAN stream buff load. Let's just double check so I need a channel and a file name. So I'm going to do TX1, and I'm going to do, let's do this guy here. So that loaded that IQ data into the buffer, the DMA buffer on the device. It loaded the entire file because the file's local, so it knows how long it is. Now, when we do a stream start, we need to put in the channel. We need to tell if it's cyclic or not, meaning do you want to repeat the buffer over and over and over, or just do it once? We'll repeat it so we can visually see it. So I'll do a 1 for cyclic or true. And then sample count. I don't recall how many samplers are in this file. I know it's large. It might be 38,000. I'm just going to do 10,000. So it's going to repeat forever the first 10,000 samples of that file. Once I hit go, you can see it starts transmitting. I can do ADRV get param TX1 carrier frequency, and you see 2.45, and that's what we're on our spec amp. Now if you want to stop the stream, you just do an RFLAN stream stop with TX1. So the CLI commands are just very basic ways to configure the hardware and interact with it. You can receive stuff. You can receive IQ data over the CLI. You can go to a calibrated mode, enabled mode. You can execute a script that you have put on the device that has a combination of CLI commands in it. But what really ends up making this useful is if I'll just close the CLI. I'll go over here to MATLAB. In the BytePipe SDK folder, there are several MATLAB examples. And I'm going to do txstream file, which I believe I've opened. I'm going to do tx1. First, I'm going to connect. So I'm instantiating the RFLAN class and opening a COM port. And now when I run this portion of the script, it is going to transmit using port 1. cyclically, meaning forever. I am going to set the attenuation and boost. I'm going to load that same file. And these are all just CLI commands. You'll see them being sent here. It's just an automated way of doing it. And not to mention you can use all the tools in MATLAB to process data. So I'm going to hit Control Enter here and run this portion of the script. So you see that it set some things. It's actually missing some in this display of the early on stuff. Well, I guess no, it did get enable delay. It just missed these commands. That's just because they came in faster than the PC could keep up. And we got carrier frequency, sample rate, so we're transmitting just like we were before. We can do an RF land stream stop like we did before. If I want to create my own IQ data, I can do this example here. And what I did here was I just generated a transmit tone at a factor of the sample rate. So I am saying the tone is Fs divided by 32. Create the IQ data, put it in the buffer, start the stream, and then plot the transmitted waveform. So I'll do that quick here. So what was plotted was just a simple sine wave with a carrier frequency, a baseband frequency of Fs divided by 32, and you can see that's here too. So this should be offset just slightly from 2.45 gig, which it is. I can stop that. So transmit is basically I want to transmit a buffer that I loaded. Can do it forever, can do it very briefly. Now receive, if we want to do receive, there are examples for receive. So I'm going to do RX1. I'm going to do 2,000 samples. And then I'm going to plot it. And I'm going to do that 15 times. So it's just going to pause in between and get 15 different spectrum plots. So I do have a signal generator hooked up too at this frequency. It's not on yet, but once I turn that on, you should be able to see it. So I'm going to start running that. Here are the plots. And now I'm going to press the button on my SIGGEN. You can see it popped up on the SpecAn, and there you can see the received spectrum. The SIGGEN's at 2.4505 gigahertz. So just a slight offset from the carrier frequency, which is why you see the sine and cosine here. So that's basically it. The CLI application is really meant to be a small, easy to get started with application that gives you access from a command line interface to the ADR-V 9001 and some DMAs. That allows you to transmit and receive to and from the PC, and it's pretty basic, but it gives you the tools you need to start developing a product and start evaluating the BytePipe.